It's been quite some time since I've posted, but since I have some free time now, I'm going to start posting again. So, today we're going to be covering an Algebra 2 topic, common graphs and their transformations. This is widely important just because it also shows up later in pre-calculus and probably will continue to show up after that. I know there's a lot of trigonometry in calculus, so these are pretty important to learn and to fully understand. So the most common graphs are listed here. We have a constant, linear, quadratic, cubic, square root, cube root, sine, and cosine. Now, what exactly do these graphs look like? Well, I'll start. A constant graph is your very basic just y equals something graph. So we'll say it's y equals k. And it's just a straight line for wherever k may be. Now, we have a linear graph, which I'm sure everyone is familiar with. It's a very common Algebra 1 topic. We have y equals mx plus b, and we all know that m is the slope and b is the y-intercept. So I'm going to go ahead and just draw this again, just to refresh everybody's memories. It's going to look something like that. I'm sure there's very many types of lines you could draw, but that's just a very basic one. Quadratic, we're going to talk about parabolas now, y equals x squared, for example. And it's going to look something like that. A very basic parabola, again, it can open upwards or downwards depending on your equation. We'll get more into that in another video. Cubics, y equals x cubed, I think you could guess. And it looks like something like this. It's very similar to a tangent graph, which is not listed here, but it looks something along those lines. A square root graph is y equals square root x. Now this is an interesting graph just because you'd expect it to look similar to a quadratic, but it is kind of similar, except a part is omitted. So if you were to turn a parabola sideways and then get rid of this bottom part, that's what a square root graph looks like. And we get rid of the second part just because if it has another part to it, then it would not be a function because it doesn't pass the horizontal line test. Just like that, that has two solutions, which it is not a function. A cube root can have, does not omit any part. If you were to think about a cubic graph, being rotated, it would be exactly. So it's going to look something like this. It's kind of in the wrong direction, but you get my point. Now we're going to discuss two of the most common trigonometric graphs, sine and cosine. There are two graphs that look almost identical, so you might be wondering, what are the difference between these two? Well, let me tell you one key difference between a sine and a cosine. A sine will always pass through the middle of the graph, the center. Always. Unless you're applying any shifts to it. I drew this wrong. But it has points that'll pass through, and then it will just look something like that. But it always passes through the center, and that's one of the most identifying factors of a sine graph. Now, a cosine graph is going to pass through not the center, but rather intersect the y-axis, and it's gonna have roughly the same shape of a sine graph, just if it was shifted a little bit. After that, we'll be talking about transformations. Now, these are the most basic graphs. I mean, I didn't write any equations for this, but it should be y equals sine x, and then y equals cosine x. Very, very just basic graphs. You may notice that in this linear equation, I said m and b. Now, these are factors of transformation. So the b will raise the the y-intercept up how many, I would say, notches or units. And then the mx, although you can't really see that m working into place, it does transform it in a certain way. So I wrote out these transformations pertaining to a quadratic formula. So we're going to start off with our very basic quadratic is y equals x squared. If you're going to add plus b, you're going to make the graph go up. So let me just draw a quick parabola for reference. This is your parabola. If you want to move it up, let's say 1 unit, that bottom is going to go up 1 unit. And if you're going to subtract b, it's going to go down 1 unit, or down b units. Now, if it's in these parentheses, if it's being squared with the x, it pertains to the x, and therefore it's going to move left or right, depending on your sign again. So, if it's plus b, you're going to move to the left. How many units? And if it's negative, you're going to then move to the right. How many units? After that, you have vertical stretches, which are on the outside of the parentheses. And this kind of changes what the graph is going to look like. So if I want to stretch it, how many units? It's going to get, oh, I can't do it. Okay, well, for when a is greater than 1, let's say a is 2, it's going to be stretched vertically. So let's just plot some points. It's going to get wider per se. So it's going to look something like that. While if a is less than 1 but greater than 0, this is a vertical compression, and it gets, I would say skinnier, slimmer. What's the right word for that? Anyway, it would get thinner, perhaps, like that. So a must always be greater than 0 for like at the moment. As we've gotten to this point, a is greater than 0. But when a is greater than 0 but less than 1, that means it's a fraction. It could be any fraction, whatever your heart desires. And then for your stretch, it's just a whole number that is greater than 1. For horizontal stretches, it's flipped. So if you could imagine the exact same thing happening, it's just pretty much flipped. And then we have our flips across the x and y axis. So as I mentioned earlier, the parabolas can open up or down depending on the sign. If the sign is negative, it's going to open downward, and if the sign is positive, it's going to open upward. And this is on your outside of the parentheses, while on the inside of the parentheses, just because this parabola is symmetric, you can't really tell. But if you're going to have a flip over the y-axis, these points here are going to transfer to these points. Maybe I can show you a better example with a cubic. If I'm going to flip it over the y-axis, now it's going to look something like this. And look, you've got DNA. Oh, your RNA. Sorry, I'm bringing biology into this. I really shouldn't. But those are your transformations and common graphs. Feel free to ask any questions in the comments.